Hi, welcome to lesson 22, session 3. We are going to be continuing our work multiplying with multiplying fractions and word problems. Today we're going to be adding in the element of multiplying mixed numbers, which is brand new to most of us. Now, we've touched a little bit on how to change a mixed number to an improper fraction, but today we are going to learn how to do that so that we can properly learn how to multiply fractions. So we're going to work on that today. So go ahead. We'll be working today on pages 447 through 452. So go ahead and open up your Ready Classroom Math Workbook to page 447. All right. So today we're going to be looking at this problem, and the problem says this. Janie has a rectangular garden that is 2 3/4 yards in length and 1 yard in width. She grows roses in half of her garden. How many square yards in Janie's garden has roses? So we know that Janie has a garden that is 2 3/4 yards long and 1 yard wide. And we know that she grows roses in half of that space. And we want to know how many square yards in Janie's garden has roses. So what are we talking about? We're talking about a garden with roses. We want to know how many square yards in Janie's garden has roses. And then the important information is, the important information is that we have 2 3/4 yard garden that is 2 3/4 yard in length, 1 yard in width, and that half of the garden is covered in roses. So I want to draw a picture of what this kind of looks like just to help us start us out. So we know that we have a garden that is, I'm going to go ahead, I'm going to use the method that we learned a little while ago about, we're going to change 2 3/4. We're going to change those into unit fractions. I think, no, we're going to make an area model. I changed my mind. So we know that we have the garden is 1 yard wide. So this is going to be our 1 yard wide, and it's 2 3/4 long. Okay. Now, if we were showing this 2 3/4, that means we have 2 holes. And then the final part is showing 3/4. So if we had a third hole here, we would break it into fourths. And so then we would shade in. So we know that we have shaded in 2 holes. Not my best coloring job. So we have 2 holes, and then 1, 2, 3/4 of a third hole. Okay, would you agree with me that from here to here is 1, from here to here is 1, and then 1/4, 1/4, and 1/4. So if you added up 1, 1, and 3/4, you would get 2 3/4. Now, we know that half of the garden is covered in roses. So I'm going to make that pink. And this is 1/2 of the entire garden. Now the garden stops. I want to show you guys. I'm going to erase this part of the garden because that's where the garden stops. Okay, there we go. All right. And then we've got half of the garden that is covered I am going to leave, sorry guys, I keep throwing you off, but I am going to leave that section there because although it's not part of the garden, it does affect our fractions. So we're going to talk about that in a minute. So we can see here that we have this right here is 1/2 of a whole, because as you can see, this is a whole and we've shaded in with yellow and pink half. This here is another 1/2 of a whole. And then here, this section here would be 1 out of, and if you look at just this whole, how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8 parts in this whole. So that is 1/8, this is 1/8, and this is 1/8. So hopefully that somewhat makes sense, but we're going to do an equation in a minute after we finish this area model. So if we added together a half, an eighth, an eighth, and an eighth, we would get 1/2 plus 1/2 equals 1 whole, and then 1/8 plus 1/8 plus 1/8 equals 3/8. So 1 3/8 of the garden is covered in roses. Now, I'm going to show you how to do this as an equation, because this the area model, while it gives us a great visual, that might not be your best method. So I want to show you another way that you could do that. So this is what you could do. We want to know what is 1/2 of 2 3/4, or what is 1/2 times 2 3/4. Now, when we're trying to multiply fractions, we can't multiply, well, we could multiply like 1/2 of 2 and then 1/2 of 3/4, but there is a way to do it all in one step instead of breaking it apart into 2 different equations. What we can do is we can change this 2 3/4 back into it. We can change it into an improper fraction. So to do that, we can do it a couple of ways. The first way that we can change a mixed number into an improper fraction is we can, keeping this same denominator, we're going to, as many wholes as we have, so we have 2 wholes, one whole would be 4/4 because our denominator is 4. So 1 whole is 4/4. 2 wholes would be another 4/4, and then we have 3/4. So to change this 2 3/4 into a mixed number, all we need to do is break it up kind of into like a weird expanded form and change it into 1 whole plus 1 whole plus 3/4, which is, then we can just add all of our numerators, which gives us 4 plus 4 is 8. 8 plus 3 is 11. And then our denominator stays the same. That's one method. In my opinion, a simpler method is this. If we have 2 3/4, what you're going to do is you're going to start with your denominator. You're going to multiply your denominator times your whole number. So your denominator times your whole number equals 8. Then, after you multiply your denominator times your whole number, you're going to add the product of 4 times 2 to the numerator to get your new numerator, and then the denominator stays the same. So, multiply the denominator times the whole to get your equal number of parts in 2 wholes. Then you're going to add that equal number of parts to 3 to get 11. So as you can see, all we did here was this 2 times 4 gives us 8. That is the same as if we added 4/4 plus 4/4, it would be 8/4. That's how we get that 8. So either of these methods will work, but then once we've changed this 2 3/4 to 11/4, all we have to do is 1/2 times 11/4. And then that's going to give us 1 times 11 is 11. 2 times 4 is 8. Now, the only funny part is we did all that work to make that mixed number into an improper fraction, and now we're going to take that improper fraction and make it right back into a mixed number. So then we're going to change this back into 8/8 plus 3/8, which equals 1 3/8. So there's a lot of converting. I don't know which method is going to be best for you, but I do know that if you choose to use the equation, you do need to change this mixed number into an improper fraction before you can multiply it. But again, we're on the next page, we're going to go over a couple of different options as well. So go ahead and turn to page 448. All right, on page 448, we see the area model that we drew. It looks almost exactly the same. They even left that part on the end, which I decided to tack back on at the end. As you can see here, this is 1/2 of a whole. This is 1/2 of another whole. And then this is 1/8 of this whole, 1/8 of this whole, and 1/8 of that whole. So we can also use equations. So the way that they did it here is exactly kind of what I showed you here. They broke apart the 2 and the 3/4. And then when I did it this way, like 4/4 plus 4/4 plus 3/4. They, in this step, just added this step together. And they said that 2 is the same as 8/4, and then added the 3/4 to get the 11/4. And then you can do the math down below to get the product of 11/8, which we then converted back into a mixed number. All right, so on number 1, it says this. Use the last equation in Model It to find the area of Jamie's garden. So looking at this section over here at the bottom left-hand corner, you can see that they asked us just to use the Model It and to solve this, which we had done on the last page. So we know that the garden has 11/8 square yards of roses, which is equal to 1 3/8 square, I don't know why that, there we go, 1 3/8 square yards of roses. Now we're going to explain how we could use the area model in from Picture It over here to find the area of Janie's garden that has roses. Well, if we look at these unit fractions, or these fractions that we have here that just happen to be unit fractions, we see that the area model shows the area of Janie's garden with the roses in parts. We see 1/2 plus 1/2 plus 1/8 plus 1/8 plus 1/8, which equals 1 3/8. If we added together all of the purple sections, that's how much of the garden is covered in roses. And then this blue section down below is how much of the garden is not covered in roses. And then just as a reminder, this section of the area model over here is not part of the garden. So don't get confused, because this is not part of the garden. Now, if we look at this first equation in Model It over here, why is the mixed number rewritten as a fraction? So why is this 2 3/4 rewritten as an improper fraction? We need the mixed number to be an improper fraction so that we can multiply the fractions. We could, there's one other way, which I'm about to show you, that we could do it, but to just do it all in one equation, we need to change that mixed number to an improper fraction. Now, how could we multiply 1/2 times 2 3/4 without changing 2 3/4 to a fraction? Well, we know we can use our properties of multiplication, and we could do this. We could find what is 1/2 times 2. So what is half of 2? That half of 2 is 1. And then what is half? Oh, wait, never mind. They're going to do it over here. Half of 2 we know it equals 1. It actually equals 2 over 2, which equals 1, because 1/2 times 2 is 2/2, which equals 1. And then we can multiply 1 times 3 is 3, and then 2 times 4 is 8. So maybe that's going to be your best method. If you're trying to do that multiplication and you're really struggling with how to change that improper mixed number back into an improper fraction, this might be your best method. It's going to cause a couple extra steps because you'll need to break it apart and do 2 equations and then add the 2 products together. But if that is your best method, then that's the one I want you to stick with. But we'll figure it out. So once we add those 2 products, we get an answer of 1 3/8, which does give us the same answer as both the area model and changing the mixed number into an improper fraction. And honestly, it saves us from having to turn it back into a mixed number. So honestly, maybe this will become my best method. I think it's kind of a cool idea. So is this result the same as our answer to problem 1? Yep. It is the same, or more formally, yes. So how can you multiply a mixed number by a fraction? In our case, one easy way to do it is write the mixed number as an improper fraction and then multiply as you would normally. And now I'm reflecting back. If we're looking at all of these strategies, again, we get strategies up the wazoo. I want you to say, my best strategy is because, and then tell me why. You can go ahead and pause the video here. Tell me your best strategy. And then when you're done, we're going to go to the next page. All right, we're going to do number 6 and 7 together, and then I'll have you do number 8 on your own, and then move on to the green pages. So this number 6 says, Izzy has 3.5 yards of rope. She uses 3/5 of the rope to attach a tire swing to a tree in her yard. How many yards of rope does Izzy use for the tire swing? Show your work. So for number 6 and 7 today, I'm going to use the equation method in both. But in one, I'm going to change the mixed number to an improper fraction. And in the other, I'm going to show you the alternate method, which I want to try out. And so I think it'll be good. So up here, we're going to start out with this. Izzy has some rope. And we want to know how many yards of rope Izzy uses for the swing. We know that she has 3.5 yards and she uses 3/5 of the rope to attach to the tire swing. So we want to know what is 3/5 of 3.5. So to do this, I'm going to go ahead and I'm going to change 3.5 to a mixed number. An improper fraction. So we have 3/5 stays the same. Now when I'm changing 3.5 into an improper fraction, I'll do it over here. So if I have 3.5, I'm going to multiply 2 times 3 to get 6. And then I'm going to add 6 plus 1 to get 7. And then my denominator stays the same. So 3.5 is the same as 7/2. And then I'm going to multiply straight across. 3 times 7 is 21. And then 5 times 2 is 10. So my answer is 21/10. But I can change 21/10 back into a mixed number. I know that 10 goes into 21 2 times, and I have one equal part of 10 left over. So the answer would be 2 1/10. So here, it didn't take too many steps. The only thing I really had to do was change this 3.5 into an improper fraction, and then multiply, and then change this improper fraction back into a mixed number. Now let's try number 7 using a different method, but still using an equation. So it says this. Colin has a chain that is 5/6 of a foot long. He adds links to his chain so that it is 4.5 times as long as the original chain. How many feet long is his chain now? Show your work. So we know we're talking about a chain. We want to know how many feet long his chain is now. We know that his chain is 5/6 of a foot long, and then he adds links that are 4.5 times to make it 4.5 times the original length of the chain. So we want to know what is 4.5 times more than 5/6, or what is 4.5 of 5/6. So I'm going to actually break this into two different equations. I'm going to first do what is 4 times 5/6, or what is 4 of 5/6. And then I'm also going to do what is 1/2 times 5/6. So what I'm doing is I'm breaking this 4.5 into two parts. So 4 times 5/6 and then 1/2 times 5/6. So remember, whenever you have a whole number, if you can rewrite that as a fraction of the whole number over 1. So 4 times 5 is 20. 1 times 6 is 6. So 4 times 5/6 is 26. Then 1 times 5 is 5. And 2 times 6 is 12. Now, this method is not working out to be quite as nice as I would have wanted it to be, because right now I'm going to have to make these, in order to add these two products together, I'm going to have to make them equivalent. I'm going to have a common denominator. So I happen to know that 6 goes evenly into 12. So I'm going to have to multiply this 6 times 2 to make it a 12. And I'm going to have to multiply this 20 times 2 to make it 40, so that I can add 40 twelfths plus 5 twelfths, which equals 45 twelfths. Now, I don't know if that is the fastest way to get to that. I'm kind of starting to second guess myself and think that the best method is probably going to be just to change that number into an improper fraction. But then I can figure out how many times does 12 go into 45 evenly. I know that it is that is the same as 12 twelfths plus 12 twelfths plus 12 twelfths, because 12 plus 12 plus 12 is 36. And then I have 9 twelfths left over. So my answer is 3 and 9 twelfths. I don't know if that was the best method. I didn't like it that much. But again, it might be your best method. I don't think so, but it might be. So what I'd like for you to do on your own right now is go ahead and find out what the answer to number 8 is. It says this: George has 1 5/9 yard of fabric. He plans to use 3/4 of 1 5/9 of the fabric to make a pillow. How many yards of fabric will George use for the pillow? So you're going to be solving the problem. What is 1 5/9 times 3/4? If I were you, I'd go ahead and turn this into a mixed improper fraction. Actually, in case, I'm going to help you. So 9, remember, multiply the denominator times the whole. 9 times 1 is 9. And then add the 9 plus the 5 to get your new numerator. So what you're going to do is multiply 3/4 times 14/9. And then you're going to get an answer. And then you're going to make this improper fraction into a mixed number and get your answer. Today was a doozy. I think that you're with me. I'm feeling it. I'm feeling like you're hanging with me. You do have a fluency practice today, and you also will have pages 451 and 452 to help you. If you are struggling or have any questions, please, please, please reach out to your teacher. We are here to help you, and I know that Especially trying to do this on your own isn't always the best. And so I want you to please reach out to your teacher if you're struggling or have any questions. See you next time.